NPI.
Ion NPI brought to you by Digi-Key. This week it is analog devices. Lady Ada, what is this week's Ion NPI?
I'm glad you asked. This week's NPI is the Essential Analogs Toolkit with the Efficient Power Set. This is from Analog Devices. It has a lot of Maxim parts because don't forget, Analog and Maxim are now best buddies. So this is what the kit looks like. It's a really good deal. You get 9 dev boards that all feature different modules or chips that are kind of like the leading edge of analog devices power supplies. So let's go to the overhead. I'm going to show off the modules really fast, and I'm going to go through each of the 9 modules. So this is the kit you get. So it's super cute. Scan, it'll take you to the website where you can get more information on each module. And then what's actually kind of nice, it's a little detail, but the material that the PCBs are on, it's like that sticky stuff that when you put like your phone on, it like sticks, not permanently, but it's like a really solid connection. So just watch out, like it looks like they're floating, but actually they're stuck on this kind of gelatin material. So there's, like I said, 9 different modules. These 8 are like pin compatible. They use the same 0.1 inch header breakouts on the left and right for input and output. So you can, plug and play them into a dev board if you want. This one is a little bit unusual. We'll get to this one. This is the reversible power supply, and it has a 1 farad super cap on it. That's 1 farad, not microfarad, 1 farad. So it's a little bit bigger. However, all right, so let's show these off. So there is the MAXESSENTIAL 38643 nano power buck module. There is the sister MAX 3864A40A nano power buck. That's the non-module version, which I'll will show on in the later slides. We've got 2 boost converters, also kind of similar. One is the Max M17225, a boost module, so it's tiny, and then the larger Max 17227A boost chip, which has all the parts next to it. So 2 boosts, 2 bucks. There's 2 buck boosts, the Max 77839 and the Max 77827A. And then 2 LDOs, so low dropout regulators, the 38902 and the 38913. And finally, this large one over here is the Max 3889 continual reversible buck boost. This is kind of neat because it's a buck boost that goes either direction, and it uses a super cap as the battery backup. So you can buck boost into the super cap as a battery backup and then select when you want to then change over and then power your circuit from this backup power supply. So you get like 9 full modules, and each one of them, basically all you need to get started. All the buck boosts, LDOs, etc., have selectable V-outs, and you can adjust that with little jumpers here. By default, it's 3.0, but you can select different jumpers, it looks like, to change the output to 2.5 volts or 4 volts or 3.3, but they're all kind of default 3 volts output. So let's go through each of the 9 real fast. Oh, and this is what it looks like. It's a nice photo. So the first one is, okay, the first one, let me get my stuff set up here. This is the Max 38643. Hold on. Yep. So each one comes with, so each one, apologize. This is the data sheet for the kit, which contains a list of all of the modules. I was like, wait, which data sheet is this? So it has the 9 modules, so you can see on the left, it has the 9 chips indicated, and it kind of goes through each module. There's a little quick description of each module. You get, with each board, the schematic of the module or chip, so you know like what the module has, and you'll also get the 4-layer board layout showing the power ground signal layer for the board. So if you want to duplicate this power supply into your setup, once you've tested it, you verified that it works with your design, you can just basically clone their layout, so you don't have to worry about inefficiencies caused by not putting the components exactly in the same location. Like as you're getting to the 4 amp boost converter chips or the buck boost converters. It actually does matter, like where you put the capacitor, where you put the inductor. So I would just recommend just follow their design as much as possible. Okay, now we're getting to the chips. So the first one is this nano power buck module. So what I like about this, it runs, first off, it's got super low quiescent power supply, only 330 nanoamperes, which is really small for a power supply. Second, it's got, this is the module version. So the inductor you see in this schematic, the inductor isn't shown. That's because it's on top of the chip itself. So it's very small. It's a little bit more expensive because again, that inductor is placed on top, but you only need one small resistor to select the voltage and a couple of capacitors on the outside for the input and output. Otherwise, it's completely self-contained. You can adjust the output from 0.5 volt to 5 volt output, 600 milliamps of current capacity, and the input is down to 1.8 volts. Otherwise, it's just extremely small. I mean, this is a tiny little module, and then all you have to do is add some 0805 capacitors on the outside. You've got a nice ultra compact power supply, good for wearables. I thought this would be if you were designing a wearable or a medical device that somebody would have in their wrist or their finger. Then this would definitely do the job. Next up is the MAX38640. So this is the chip version of that module. So this version, you see that it does have the inductor visible, so it's going to take a little bit more space. But because of that, you can go a little bit higher, 700 milliamps. It's otherwise basically the same chip, same input and output and settings and efficiencies, basically. But you have to use a little bit more board area, but it costs a little bit less because you don't have that funky inductor on top module. Next up, the boost converters. So this one is kind of neat because it runs down to 0.4 volts input. Like the minimum startup is 0.88 volts, which means it can basically run off of a AAA battery or even like a small coin cell battery, 1.5 alkaline, very easily. It's got really low quiescent current, again, only 300 nanoamperes. This is the module version. So again, the inductor's on the top. You only need capacitors on the input output and the R cell, 1 amp peak inductor current. So just do the calculation. If you're boosting from 1.5 volts to 3, you're going to maybe get 250 milliamps out. Likewise, they also have the MAX17227, which is a slightly higher current version, not module. So you would have to add the inductor on this one, but higher current switch. Same runs down, it starts up as low as 880 millivolts, up to 5.5 volts output, selectable with a resistor. You just need capacitors on the input, capacitors on the output. You need that inductor because it comes in a TDFN or WLP, and then a resistor to set the output. Very, very low quiescent current as well. So really tiny. And I also think it's neat that as the voltage dips down to like 400 millivolts, it'll still run. So also good for very small wearables that run off a very tiny battery, especially a little coin cell or AAA or alkaline button battery. Next up, the MAX77827. So now we're getting to the buck boost. So again, really low quiescent current, only 6 microamperes, 1.8 volts to 5.5 input, 2.3 to 5.3 volt output. There's 2 iLimit mode internal switch limits, 3.1 amp or 1.8 amp. So, you could get up to an amp output at, 1.6. Yeah, sorry, 900 milliamps output at 3.3 volts in boost mode with a V in of about 3 and a V out of a 3.3. Pretty efficient, but basically this would be good for when you're dealing with a lithium ion battery. The input voltage of the battery can be 3 to 4.2 volts, but you want, say, 3.6 or 3.3 output. So you want it to run even as the battery starts dying, gets down to 3 or 2.7 volts. You want to have a stable output. This buck boost converter will do the job. On the module, they have the WLP version, but it does come in a QFN. So, if you're a little like me, you don't really like hand soldering WLPs, the QFN is also available. Also, really high switching frequency, 2.5 megahertz. So you're going to get very small inductors there. Next up, the MAXESSENTIAL02EP. This one, very similar. I think this was the one that had higher current output. So this one is 4.4 amp or 3.6 amp current limit. So, you can, I think, get 2 amps out 3.3 volts. So like this one is a very high current output compared to the previous one. So good if you have a much larger battery, you need a much larger power supply for, whatever your project or product has a 2 amp current requirement. But otherwise very similar chip to the previous one, the 77827. This one is the funky one. This is the reversible buck boost, which I'd never seen before. So it's kind of interesting to read about this. So this chip, as you can see, I wanted to include the application diagram because it's got the charge enable and the backup enable. So basically you can configure which way does the power go. Do you have the power charge the super cap, which is on the left, it says 10 farads. On the dev board, it has a 1 farad capacitor. Or you can then switch it over and have it charge the system. The reason you might want a buck boost for the the backup super cap is that a lot of the super caps have a max voltage of 2.7 volts. So if your main system is 3.3, or maybe it's running off of a lithium ion, so it's like 3.7 volts or 4 volts, you want to efficiently charge that super cap. You'll want a buck boost, and then when you're ready to run your system off of it, you buck to 2.7 volts to charge up the super cap, and then you boost from the super cap up to 3.3 volts to run your project. So kind of a cute idea of using one power supply chip in either direction. Interesting design use. I mean, I'm sure this was used for a particular product, but they in the possible use cases, they're like, oh, this is for solar projects or for power monitoring projects where you'll have something that maybe has to get some power very quickly and then has to run a real-time clock off of a super cap for a while. Okay, then finally we've got to the LDOs. So these LDOs, I'll say that they do have higher quiescent current than I'm used to. So this one has, 365 microampere quiescent current, but very low noise and surprisingly low dropout. I was actually kind of shocked. I think this one and the other, this one has 100 millivolt of dropout, even at full current, which is quite a bit. Usually if you're trying to get a LDO and you want 500 milliamps out, you're going to end up, spending maybe a quarter volt or 300 millivolts, 400 millivolts on the dropout. But this one actually is only 100 millivolts. So it's very low and, very high accuracy, very low noise. So that's what you'd use this one for. And then it has the other LDO, which is even lower noise, only 4 microvolts RMS. And this one has even like ridiculously low, I think it was 33 millivolts of dropout at 3.3. Sorry, 33 millivolts dropout, 1 amp load current, 3.6 volt supply, 28 millivolts at 5 volt supply. So ultra low dropout. But in exchange, you're going to get a higher quiescent current. Trying to think, this no load quiescent is 1.4, 1.37 milliamps. So it's a little bit higher quiescent, but you get extremely low dropout. So if that's a trade-off that would be useful in your product, then this is a very, very nice low dropout regulator with 1 amp output.
All right, and it's available on Digi-Key.
That's right. Both the kit, which again is a very good deal because you get 9 modules all ready to go, and the individual chips, which in the text for the NPI, I have all of them labeled out, all those are in stock. So, after you try out the module, you like the power supply, you want to duplicate it. All those chips are also available on Digi-Key, and they're in stock even,
Yeah.
which is amazing.
All right. And then we have a video you wanted to play?
Yes, they have a really nice app which does product comparisons, and you can do quoting and get samples. So don't forget, if you want, you can get samples of these chips, Maxim analog devices. They all have really, really good sample programs. So, get 3 to 5 chips as you're designing your product, prototyping. Use the modules to start, then get the samples, and then book your reels on Digi-Key.
We're going to play the video, and that'll be this week's Eye on NPI.
Ever find that you need to review technical details or look up IC specs, but you're not in front of your computer? Whether you're working from home, in the lab, or outside, Maxim Integrated brings analog expertise directly to you. Our new Essential Analog mobile app provides quick and easy access to smart, essential analog ICs, perfect for engineers like you who are building innovative, next-generation systems. Search and select parts faster with the app's quick, intuitive interface, even while offline. Get notifications for events and new products based on your location and product interests. Read the news feed for the latest application notes, webinars, and design solutions, all produced by our system experts. Add favorites for products, content, and searches you'd like to access later. Watch informative videos highlighting Maxim's best essential analog products, which are available on our free toolkit, and access samples, purchases, and more. Now, Maxim Integrated puts essential analog right in your hands. Download the app on your phone today.